Now, last part about the bivariate statistics is about the Spearman's rank correlation coefficient. So far, we had seen Pearson's moment correlation coefficient. We did show it by R. And also we have one more type. It's a Spearman's rank correlation coefficient. So to differentiate them, in calculator we use the same for ID how to find correlation, RP for the Pearson and RS for Spearman's rank. So when we are going to use Spearman's rank, for example, when we have data like this, and when we plot on a scatter diagram, when the trend is kind of not linear, non-linear kind of relation, we only tend to use Pearson 1 when we see that there is a trend in linear correlation. But when we do not see such a correlation on a scatter diagram, we will try to use Spearman's rank to see whether they are correlated, how well they are correlated, is it strong, moderate, or weak. Okay, so how we are going to do that ranking? It can be from the lowest to the highest or higher from the highest to the lowest, doesn't matter. Let me just use, okay, we'll open new row, for example, for the longest jump. And also let me do it upwards for the speed. So let's indicate the ranking for them. So it's up to you how you are going to do it. Let's go with the highest one. In your book, it goes reversal from lowest to highest. Let's go with the highest one. Which one is the highest one? I guess 8.96. So I will call it 1. Then after 8.96 comes 8.92. I will rank it to second place. Then after 8. This one I guess 3, 8.84. Then comes 8.72, which is 4. Then comes 8, which is 5. So in total 8 athletes. So then comes this guy. 2, 3, 4, 5, 6, 7. How many people I have? It's not 8. 8, 9, 10 people. Okay. Then comes after 6, 7. This one will be 8. And this one will be 9 and 10. Then for the longest jump, again, we did from the highest one. So what's the highest rank will be here? We just go and find it. It's this guy. Then comes this guy. Then which one comes? This, 4, 5. Then comes 6, 7, 8, 6. Okay, this one will be 7. This one will be 8, 9, and 10. Now we have new pairs. New pairs in a calculator. We are going to enter this pair: 5 and 3, 2 and 1, and 6 and 6, 7, 7. These pairs we are going to see the relation between the ranks, whether they are strong or not. So in the example, I will try to show it. Let's go with the example from your book, question number 4. If you can't see the question, you may open your book from your book. So let me explain quickly what is it. I try to make small so we can draw it. In a 60-minute art lesson, students were asked to make as many as possible paper cranes. The table shows how long it took for each paper crane for each student to make a paper crane, and how many cranes they made during the lesson. So here the cranes 9, time taken 6 for second student. Oh, okay, 5, 9.5. So there is a relation given. Let's draw a scatter diagram. I guess I didn't draw scatter diagram. Always I use the calculator just to make sure that we understand. Let me do it by hand. How we draw scatter diagram. So in x-axis we will put time, and here the cranes, the number of cranes. Then I look at the time. At most, how many minutes? 10 minutes. So at least 4. Okay, let me go by 4 minutes, 8 minutes, and 12 minutes. Do I have more than 12 minutes? Oh no, I put in a crane. I have to do it down. Okay, the time is kind of different. So let me go by 2 because, okay, let me go by 2. 2, 4, 6, 8, 10, and 11. So let's put 12. Then I go with the cranes, the crane 4, 16. Okay, let me go with the 4, 8, 12, and 16. And we need to put them, the points, yes. So 6 and 9, 6 and 9, somewhere here, correct. 9.5 and 5, 9.5 and 5, somewhere here. Then what do we have? 4 and 16, 4, 16. We do it here. 5 and 11, 5 and 11, somewhere here. 8 and 6, somewhere here. 7.5 and 7, somewhere here. 11 and 4, 11 and 4. Then it goes 6.5 and 8. So it may not be that linear, maybe I was not that accurate, kind of goes as a curved one. Okay, so still we can calculate. Okay, we drew the scatter diagram, calculate the Pearson's correlation. What do? We go with calculator. We do it by calculator. We go to the menu, statistics part, then we enter the data. So what do we have? 6, 9.5, 4, 5, 8, 7. Now I fixed the calculator. If you go to the regression and check it, what's the Pearson's correlation? Minus 0.921. Okay, let me write it. So the correlation, Pearson's correlation, 0.921. So it's a negative, strong correlation between the variables. So as its trend is not that linear, we should go to check with the Spearman's correlation. But before doing it, we need to give the ranks, as I did it before. We should give the ranks. We are just to make it convenient. I will put just extra rows above and below. And let's see. Let's give them rank from the highest to the lowest. It doesn't matter, you can go from the lowest to the highest. So the highest one is 1. This one, 9.5. Then after 9.5 comes 2 here. Oh no, 1 is this guy. Oh, I missed 1, 2, 3. Then comes 4, 5, 6, 7, and 8. Let's do the same for the cranes. So 1, 2, then comes 3, 4, 5, 6, 7, and 8. Now let's check again. Rank for time. This one rank for cranes. Now let's check them. As we have 8, that'd be 2, 4, 6, and 8. 2, 4, 6, and 8. And let's try to put the points. Now I have 6 and 3. For 6, it's 3. Where is it? Here it is. For 2, it's 7. 2, 7. Here it is. For 8 goes 1. Here it is. 7 and 2. And 2. Then it goes 3 and 6. 3 and 6. 4 and 5. Here 1 and 8. 1 and 8. Then goes 5 and 4. 5 and 4. Oh, look, linear, almost perfect, I guess. Almost perfect. Let's check it. What do? Again, we will do the same thing, but instead of now data, we'll put the ranks. So and let's do for the second one, delete all. So we go 6, 2, 8, 7, 3, 4, 1, and 5. 3, 7, 1, 2, 8. Now let's check the graph first, the scatter diagram. Oh, look, linear, again, kinda negative, strong, very strong correlation. Let's calculate the regression. So from regression, as you can see, -1. So perfect. So from the regression, Spearman's coefficient, RS, equals to -1. So we did rank them, we did this part, we did BA, calculate Spearman's rate correlation coefficient, we did -1. Which correlation coefficient is more appropriate to use for these data? Explain yourself. As this trend, here we can't see it perfectly. If it's not linear, it's better to use Spearman's correlation. Describe the correlation between the variables. So it's a negative. What can you say? Negative. Strong correlation. Now, when we use one more time Spearman's rank, when we have nonlinear correlation. For tight ones, for example, when you have two same ranks, 7 and 7, same values, for example, 7 and 7, how will you find their ranks? For example, if you go with the rank from the lowest to the highest, let's do from the lowest to the highest. Let it be this one 1, it will be 2, 3, 4, 5, 6, 7. If you have the same values here, the ranking, how will we rank them? We'll just take the average. It's not 5, it's not 6, it's a 5.5. So if you have same values, their ranking just go with their average.